In this, I'm now going to continue on with the 2017 HSC Engineering Studies question. For this question 24, I'm actually going to leave this one and come back to it. So it might be a little bit out of sequence the way that I put these up. The reason for that is because I don't have a drawing and I don't like the way that they've answered the question. So I'm going to do that one as a separate one when I feel like drawing something on the whiteboard. Again, I don't have a drawing here, but so first of all, we need to find the reactions in point B. It's a truss. I'm glad there's a truss because there should always be a truss in every... Well, I think bending is more important than truss, but I've learned that students should prepare for there to be a truss question. Okay, so what we're going to do is we're going to take some of the moments about A to find the reactions at B. So let's have a look. We're going to have three forces in this reaction. We're going to have this 3, and how far away, what's the perpendicular distance of this force? Force 3, what's the perpendicular distance? 1.5 meters. Yep. Okay, so is it going clockwise or anti-clockwise? Relative to A, it's going clockwise, yeah? Clockwise. Okay, so it's going to be 3 times 1.5, right? Positive. Then we've got 20. Is it? It's how far away? 3. 20 times 3 going anti-clockwise. Yeah, because we're going down, down, anti-clockwise. Then we're going to have B. Now we're going to assume... Which way do we want to assume? Do we want to assume it's pushing left or right? I don't care. We're going to assume it's pushing to the left like Beyonce, right? Now, that means that we're going to say that we're going to assume if it's going left, it's going clockwise, which means we add it. Yeah? If it's going clockwise, which means we add it, we're going to say, so we're going to take 3 times 4.5 minus 20 times 3, sorry, 3 times 1.5, and we're going to have minus 20 times 3 plus B times 1.5. Let's have a look at the thing. So we've got 3 times 1.5 minus 20 times 3 plus B times 1.5. They also went left like Beyonce. Now, what we end up getting is we end up getting a negative... No, we don't get a negative number. That's good. Okay, 5.5 is the answer we get, which means that it is going to the left. Our answer was positive, which means our assumption was correct, which means it is going 35 to the left like Beyonce. Okay. Now, we also have to figure out the vertical component. What's the vertical component of A? 20. 20 up. Yeah, because we've got 20 going down, we need 20 going up. But A is the only dude who can do it, right? Now, we know that A is going up that much. We know B is going down this much. So now we need to do the sum of our forces to figure out what its... We know its vertical components. We have to figure out its horizontal component. We had 37 to the left and 3 to the left means we need 40 to the right. All right. We use our Pythagoras' theorem, which means that the value is 44.7. The angle using the tan rule is going to be theta equals 26.6. Okay, so that's how we do that truss. That's how we do the reactions for that truss. Now, what we need to do is we need to find the reactions at member C. So if we cut through member C like this, we need to find what the reaction at C is. Now, we still have this member here. We could call this member A, and we could call this member B. Now, we don't want to have member A, and we don't want to have member B. Just for the sake of the question, we're going to go and we're going to look at the answers. So we don't want member A, we don't want member B. So what are we going to do to eliminate those? Okay, we have two choices. We can use the lone wolf, or we can use the meetup. Lone wolf works when only one member can deal with forces in a direction. But we're going to use the meetup method. We know that both A and B meet up at what point we're going to call point X. When we take moments about point X, we only look at the left-hand side. We ignore the right-hand side. We could either do the right-hand side or the left-hand side. We're going to use the left-hand side because it's probably a little bit easier. So we're going to use the left-hand side. We've cut away the rest of the truss. We're ignoring that. We're now just looking at this part of the truss. Relative to point X, we have... I'm going to start here. 3 times 1.5 minus, because it's going anti-clockwise. We have 1.5 times 20. I would write 20 times 1.5 because I always like having the force times distance. It's positive because it's going... Why are they going... They're setting anti-clockwise as... Why would you do that, buddy? Why would you reverse it in the same goddamn question? Like, make me so cross sometimes. And they even use the right symbol here. Anyway, yes, makes me really cross. Okay, but then we've got the unknown, which is FC times 1.5. Put all that in the formula, and what do you get? 17. Now, is it in compression or is it in tension? Now, when they said minus 1.5, they said that we're assuming it's going to be going clockwise, and they've set anti-clockwise as positive. Why did they assume going into the member? Why did they assume it was going in? Because we always assume in. We always... Yeah, shit. Sorry. Yeah, I'm not even going to cut that. Yeah, we always assume pulling out. We always assume tension. Yeah. Now I do feel really quite foolish. But anyway, especially because I did the big voice. Okay. Yeah, we're always pulling out. We're always in tension. Yeah, I don't know what I did. Anyway, the point is they assume compression. It's fine. What they've done is they've made an assumption. And at the end of the assumption, they've just said, yeah, it was a positive number, so our assumption was correct. That's it. Boom. Done. Move on.
So out of the nose, tension.
If you're pulling out, you're tense.
Yep.
If you're not pulling out, C. Yeah, for compression. Okay. Moving on. Now, I think that's a pretty easy question, right? How many marks was it worth? Yeah, it doesn't really. Oh, 4 and 2? Yeah, that's fair. That's fair. Okay, I would think that should be 3, to be honest. So you can get 1 mark for the working, 1 mark for the magnitude, 1 mark for the nature. Okay, explain why concrete would be a suitable material for the roadside sign. Because it can be set in situ, right? It means we can take it to the location, mix it up, and have it set there. It's also very strong. It's also very durable. That's 3 answers. Explain why. Because it can be cast. I've used the word because. Yeah. When correctly mixed, easy to place on the right side column. It gives good strength, hardness during curing. Yep. Cures, resist weathering. Yep. I said all those things. Good. Let's move on. Okay. So explain why a chassis rail should normally not be drilled or welded. Okay. It's a rail. Yeah, hollow steel section. Okay, do not heat or weld. Oh, look, it's a hard... I'm going to say why it's a hard question, right? There's 3 things that I say the most important things you need to learn this subject to not embarrass me, right? First one is you need to know that concrete is made of cement plus aggregates. You need to know that the stress formula equals force over area, unless it's bending. And you need to know that the yield stress of steel use 300, right? Now, it can be higher. If it's higher, it probably means it's got more what? Or more carbon. Yeah? Now, if we have high carbon steel and it gets hot and it cools down quickly, what happens? Martensite. And martensite is bad. It's fine if we know how to deal with it, if we know to temper it, if we know to treat it, right? And this is why welding stainless steel is a real art, right? This is why they get paid good money to be able to weld stainless steel. But that is why you don't drill and you don't weld, because that high temperature, same thing. Yeah. Okay. They actually don't mention martensite. Oh, there we go. Ah, good. I was worried. If I didn't say the word martensite, I would have been worried I'd given the wrong answer. But I'm happy with that answer. Okay, moving along. Ah, they want us to draw a weld. Okay, I'm not going to go into it. I'm just going to show you. Boom. That's a weld. You need to know how to do that. Yep, you need to know how to draw a weld. Yep. Now, important is they've told you the heat affected area. So that means you need to know where the little grains are, because that's where the heat affected area stops. Yeah? We assume that everything is cold worked. Yeah? Always assume everything is cold worked so that this is going to be equiaxed. I don't like that they've drawn circles. My teacher back in the day would have said, I don't want to see duck eggs. Right? Instead, you draw, but circles, I guess they figure that, you've only got a short amount of time. They will accept circles. Okay. Got a Pascal's principle question, right? Straight away I look at this, I see 2 cylinders, that's what I'm thinking. Okay. A force of 1 kilonewton acts on the 40 millimeter master piston, right? So this is 40 millimeters. It's a master piston. Okay, this is 100. Okay, what is the difference in their diameters? I think it's like 2.5, right? Yeah, the diameter ratio is 2.5. What's the area ratio? Which is, 1.25, right? Oh, 6.25. I was wrong. It's cool. Okay, so the ratio is 6 to 1. Now, is it the force getting bigger or smaller? Big area, big force. Yeah, bigger. So if that's 1 kilonewton, what are we getting out? 6.25 kilonewtons. Let's check that I haven't told you a story. Oh, nice. How easy was that for 3 marks? That was just a gift, right?
Oh, no, not this question. Get away.
Move along. Move along. Look, I will just quickly scroll. Move along. Okay. It is possible to do these. We have done these. I am so glad that when that test was in my HSC that I had taught that to my students, because sometimes I'm like, do I even bother with true length, right? True length developments. But they have been around enough that I do say that you should know how to do them. At least a simple one. At least do something. Put some lines down on the paper so the marker can give you something, please. Yeah? Do something so that just draw the obvious shape. The shape that you know is going to be right. Like, you know that shape's going to be right. Just draw that. That gets you 2 marks, right? Yeah, if you just draw that, you get 2 marks. Like, if you just draw that part there, boom, you've got, or, sorry, this part here, you've given me a mark, right? Okay, so, yeah, unfortunately I've asked you to draw, yes, X, yeah, it'll work, okay. Now, 20 diameter hole, punch through a sheet, stress, calculate force required to punch a hole of thickness. Okay, so punching shear, what do we need to calculate? The ribbon area, right? That means is the cross-sectional area through the piece that you're cutting. So what we need to do is find the circumference of a 20 diameter hole, right, which is going to be like 63 times 0.5 thickness. So it's going to go back down to being about 31. It's actually be pi, so it'd be 31.4. Okay, so it's going to be force over area, but we're not using stress. We're not doing stress equals force over area. We have to rewrite our formula, which means that force equals area times stress. So we've got 31.4 times 110. Let's have a look. Let's see if I got that right. Okay. Why are they using a delta? I mean, I'm a little frustrated. That definitely should be a sigma. And it's a sigma S because we're saying it's shear. Yeah? Shear stress. Yeah, compared to compressive stress. Yeah? Okay, so I said the area was 31.4. Did that in my head. All right, pretty clever. 31.4 times 110. We go together like megapascals and millimeters squared. We use megapascals and millimeters squared. That's fine. Gives us an answer in newtons. And we convert the answer in newtons into kilonewtons because... Oh, no, we could use... Yeah, we could use... No, we could have written the answer in newtons and that would have been fine. Okay. Now, this question. This is a hard question. Well, luckily, my students did get this because we'd learned about aluminium alloys. We'd learn about the series, the 2000 series is made out of copper, and copper is heat treatable, right? The 2000 series, the 6000 series, and the 7000 series are all heat treatable. What does that do? It gives you precipitation hardening. So describe the changes that occur when we precipitation harden. Well, luckily for you guys, I have a picture here, and previously I had a picture on this book. I can't remember the page, but I've said it on one of the other videos. We're going to use this steel one. It's close enough that we can use it even though we're actually talking about aluminium alloy. What's going to happen? The beta grains are going to be dissolved into a uniform 8 alpha phase, and then when quenched and reheated, we're going to have a precipitate of microscopic inclusions in